start with the first derivation in the chapter atoms. So our first derivation in the chapter atoms is radius of electronic orbit. So radius of the electronic orbit from a Rutherford model. Let's see what's there in that. So if an electron is revolving around the nucleus, if any electron that is revolving in a specific orbit around the nucleus, then we know that there are two forces acting on it. One is centripetal force and one is Coulomb's force. Let's say this is the nuclei of an atom and an electron is revolving around it in a circular orbit. Okay. Then this electron will experience two types of forces on it. One is centripetal force and one is Coulomb's force. Okay. Now the centripetal force from 11th standard, we know that it is equals to mv square by r, where m is the mass of the electron, v is the velocity with which it is moving, linear velocity, r is the radius of the orbit, and that is equals to Coulomb's interaction. What is Coulomb's interaction for hydrogen orbit? Coulomb's, let's say this is having one proton, so that will be 1 by 4 pi epsilon naught. The charge on the nuclei, that is E for a hydrogen atom, and charge on the first orbit, first electron, E upon the separation, which is r square. So it is mv square by r, which is equals to E square upon 4 pi epsilon naught r square. Now we can cancel one of the r and take the other r on the left hand side. So if I take this r square on the left hand side, this will form r square equals upon r equals E square upon 4 pi epsilon naught mv square. So r, which is the radius of this orbit, can be written as E square by 4 pi epsilon naught mv square. This is the first expression, which is very important. This is the radius of the orbit, first orbit of hydrogen atom. And if we cross multiply, the velocity square will be equals to E square upon 4 pi epsilon naught r. So v will be equals to, when you take the root, it will become E, and that will become 4 pi epsilon naught r under root. So from here we get very important outcome that we can see from both the expressions that radius of the orbit and the velocity, they are inversely proportional. Okay. So inversely proportional in a sense that if you increase the orbit, which means if you go for the outermost shells, if the electron is moving in the outermost shells, its linear velocity decreases because it is less tightly bound to the nuclei. So it is loosely bound to the nuclei, the external orbits or valence shells. Okay. So this is your expression for velocity. Now we got our expression for velocity and radius of the orbit. Let's find our energy of this whole system. So kinetic energy will be half mv square. Kinetic energy is half mv square. And what is potential energy? We know potential energy from our second chapter, K, which is 1 by 4 pi epsilon naught. Let me write 1 by 4 pi epsilon naught here. Q1, Q2 upon the separation. So let's calculate our kinetic and potential energy. Both energies are scalar quantities. So here you have to substitute the sign. If you look at this expression, here you didn't substitute the sign. Why? Because it was modulus. In Coulomb's law, this is in modulus. Okay, this is a vector quantity. I hope this is clear. So here the total energy will be equals to kinetic energy, which is half m v square. What is v square? It is written over here. So this can be written as E square upon 4 pi epsilon naught r. Plus kinetic energy, which is 1 by 4 pi epsilon naught. Charge on nuclei of hydrogen atom E. Charge on the electron minus E. Be very careful with the negative sign. So let's see what we get. This will be, now I have done a small mistake. I didn't write here m. There was an extra m also here. Okay, it's 4 pi epsilon naught r m. It is m I square. Okay, so let's substitute here m also. This m will cancel out with that m, and you left with E square upon 8 pi epsilon naught r minus E square by 4 pi epsilon naught r. I hope this is clear. Now let's take E square upon 4 pi epsilon naught common r. Here you left with half, and here you left with minus 1. In case if you have not understood, let's multiply it back. So if you multiply this factor with half, you will get E square by 8 pi epsilon naught r, and with the other expression you will get it the same. Now half minus 1 is minus half, and that minus half, when you multiply the total energy that for a hydrogen atom, that gives you E square by minus 8 pi epsilon. And this is using Rutherford model. So using Rutherford model, this is the energy of hydrogen atom. Okay, the total energy. Now you can see here the total energy is negative. Negative total energy means that our electron and nuclei, they are bounded. I hope this is clear. This is the first derivation in the chapter atoms. Let's move to the second derivation. So our second derivation is energy due to Bohr model of atom. So we have just now found the energy due to Rutherford model, and let's write here what are the expressions we got in Rutherford model. So from Rutherford model we got R, that was equals to 1 by 4 pi epsilon naught E square by mv square. Second expression we got V, that was equals to E upon root under 4 pi epsilon naught mr. And energy, the total energy we got using Rutherford model as minus 1 by 8 pi epsilon naught E square by r. Let's move to energy using Bohr model of atom. So energy using Bohr model of atom. For hydrogen atom only we will find Bohr model of atom. Okay, let's start. So according to Bohr, the angular momentum of an electron which is revolving around the nuclei for any atom, that is quantized. So how it is quantized? According to Bohr, it is L is equals to NH by 2 pi. And from 11th standard we know that the angular momentum of any revolving particle will be mass times velocity times the radius of this orbit, circular orbit, and that is equals to NH by 2 pi. So if this is equal to this, we can say R is equals to NH by 2 pi mv. I hope this is clear. Now if angular momentum is quantized, then for each specific orbit, the value of velocity and the value of radius, that will depend on n. So we can put a suffix here, Vn Rn. So Rn is equals to Rn, and for if n equal to 1, it is first principal quantum number and first orbit. For n equal to 2, second quantum number. Okay, so n is our principal quantum number, and corresponding to each principal quantum number you have a specific radius and specific velocity. That's why it is quantized. So Rn equal to nh upon 2 pi mvn. They can't take continuous values, they have to take a discrete value. So Rn is equals to nh by 2 pi mvn, and we can modify these expressions. Which expressions? The one which we found in case of a Rutherford model, and we can modify and make it in terms of n. So let's substitute the value of Vn. So if I take this expression, I can write Vn is equals to E upon root under 4 pi epsilon naught m Rn. Now if I substitute it here, let's see what we get. So from here we will get Rn is equals to nh upon 2 pi m Vn. So if I put Vn, E will be going here, and that root part that will go on the top, which is 4 pi epsilon naught m r. Now to simplify it further, let's square both the sides. So if I square both the sides, it will be Rn square, that will be equals to n square h square upon 4 pi square m square E square into this root will go 4 pi epsilon naught mRn. Now if I cancel out this Rn, if I take one of the Rn on the left hand side, this will cancel out and I left with Rn over here, and here we left with, let's cancel this 4 with 4, one of the pi with, let's cancel here only pi, and one of the m we can cancel with m. Okay, so here we left with n square h square epsilon naught upon 1 pi is left, 1 m is left, and e square is left. I hope this is clear. Great. Now this is your Rn, radius of nth orbit in a hydrogen atom. For any hydrogenic, I would say. So if we are finding the first orbit of hydrogen atom, n will be equals to 1. So if n equal to 1, R1 will be equals to, what's the principal quantum number? 1. So it will be h square epsilon naught upon pi m e square. Now look at the right hand side of this expression. H is Planck's constant, 6.626 into 10 raised to minus 34, that's fixed value. Epsilon naught from first chapter, 8.854 into 10 raised to minus 12, permittivity of free space. Pi, all of you know the value of pi. M, mass of an electron, 9.1 into 10 raised to minus 31. And finally, E, the electronic charge, 1.6 into 10 raised to minus 9. If we substitute these values, this will give us a very important outcome that is called as A naught. What is A naught? Bohr radius. Very common question in Bohr exams, Bohr radius. And this Bohr radius has a value of 5.29 into 10 raised to minus 11. Okay. Now, since we have calculated the value of R, can we calculate the value of V? Yes, you can substitute this value of Rn here. Which Rn? This is our Rn. We can substitute this Rn in the velocity to get the value of velocity. But what we are finding? We are finding energy, so let's put it in the total energy. So total energy of a hydrogenic atom will be minus 1 by 8 pi epsilon naught E square upon Rn. What is R? We just now found it is n square h square epsilon naught and pi m e square. Now if you cancel out pi with pi, anything else? No. So it will be minus e to the power 4 m whole divided by 8 times n square h epsilon naught square h square. This is your total energy. Very, very important expression. Now, if I substitute the value of E, that is 1.6 into 10 raised to minus 19, mass 9.1 into 10 raised to minus 31, N as 1 for first orbit, epsilon naught, permittivity of free space, and H, we already know Planck's constant. If we put all these values, you get a fixed value. But that fixed value will be in joules. How much it is? It will be minus 2.18 into 10 raised to minus 18 upon n square. That will be in joules. But in exams, we require it for electron volt. So this will be as minus 13.6 upon n square electron. How do we get electron volt from joules? Divided simply with 1.6 into 10 raised to minus 19, you will get it in electron volt. So this expression for total energy of a hydrogen atom or hydrogenic atom is very, very important. By substituting different values of n, you will get the energy levels. And corresponding to energy levels, you will have a different value of energies, and that will help us in understanding the line spectrum and how the electron is jumping from higher orbit